So CI CD has been gaining a lot of traction online these days, be it for marketing buzz or maybe the newcomers in DevOps. Those guys are actually enticed by what CI CD is. Adding that Docker is in the ecosystem. So doing CI/CD today is very, very easy as compared to what it was like 5 or 6 years back when there were no containers. And Jenkins used to rule the market where it used to provide you a task runner and you would define your jobs sequentially or parallelly. But it did lack some of the new features that the newest tools are providing. And that one of the new tools that we're using today is GitLab CI CD. I've been using GitLab CI CD for around 2 years now, and it has matured a lot. It provides you like very flexible options to tune and configure your pipelines in any way that you want. And many companies are also using that in production. So let's start with what CI/CD is in the first. I mean, I'm pretty sure that everybody here might be knowing CI/CD in bits and pieces, but just for the sake of the clarity, I mean, what it actually means. So CI/CD is actually a culture, set of principles, and collection of best practices that enable application developer teams to deliver code changes more frequently and reliably. And so developing and releasing software becomes challenge as team scales. So if there are a team of 2 or 3 people, you wouldn't actually mind doing everything directly. You build the code, you test the code yourself, and deploy it to the production. But when your team increases, there are a lot of interaction points, and the probability of error increases. So that's where CI/CD pipeline comes in. So if you have to remember one motto for scale, at scale, speed and consistency matters. That's the only thing that can make or break your product. So if we talk about Uber, like Uber recently published some blogs where they published that they are having around 6,000 microservices internally, and the team actually has more than 500 active developers who are contributing to these repositories. Now imagine such a system where you have to like manually build test or code, or somebody is assigned to do that. The whole pipeline will suffer, and Uber won't be able to publish changes as they're doing right now. So definitely CI/CD is the only thing that is helping companies at scale to move faster and more reliably. So now CI/CD consists of continuous integration, continuous delivery, and continuous deployment. These are not so very clear at the start, but as we'll proceed through this presentation, we'll get to know like what each phase means and how we can use each phase in our own product or companies. So like moving ahead with, first of all, continuous integration. So this is a practice that encourages developers to integrate their code into main branch of the shared repository early and often. Instead of building out features in isolation and integrating them in the development cycle, so code is integrated with the shared repository by each developer multiple times through a day. So imagine you having a repository on GitHub, and you have set up a policy that any developer can come and push in the code, but you just need to ensure that the developer is following your best practices, code styling, and most importantly, the test cases are not failing. So as long as these 3 requirements are fulfilled, you shouldn't disallow anybody to checking your code. And that is what helps companies at scale. So if you have good, pretty much standards at repository level, you can make this whole process automated. So first of all, talking about integrating the code into main branch as quickly as possible. So it reduces the cognitive load of merging large changes and thereby increases the probability of merge conflicts. So if you are able to integrate very small changes and there are some bugs, it will be very easy for you guys to fix that up quickly instead of like compiling a group of 10 or 20 commits together and then trying to figure out what went wrong. So it's a very good practice that you run continuous integration on each commit that you apply. Then comes about the cost of integration. So code styling, linting, documentation, and other static analysis can be applied at this level. So for example, you're using Python and you have a pretty much good standards at how each variable should be declared or how your file should look like. You can run Pylint at this level. So this is the stage where you can do all, you can check all the measures. So just to ensure that the code that has been introduced fulfills the criteria. And similarly in the node, you can use ESLint or maybe for any other languages. Small conflicts and errors are actually easy to fix. That's why I'm repeating this point, because if you if you check that after 10 commits, the code styling was not properly followed, it becomes really tedious for the developer and the maintainer to go back and fix them and then come back. So if there's a system that can tell you at each commit level, like what went wrong, it will be very easy to fix. And then speed is the key. So if the CI times are increasing, developers will be really and developers will actually won't use this kind of system, because that will prohibit them due to speed. So let's say you have set up a CI point in your repository and it's taking around 5 minutes for each commit. Definitely the turnaround time is so great that the developer loses focus and like concentrate on some other task. And eventually at the time when they need to integrate the code in the emergency, they will try to find other bypasses, and thereby your whole CI CD pipeline actually fails, because somebody searched for a new path that would deploy the code much faster, but in an unreliable manner. So it's very important that the CI steps that we run at each commit level are really fast, so that we don't waste developers' time. So since CI checks are at very macro level and usually fast, they're suitable to apply for each commit, and this increases the confidence about the code quality early in the cycle. So, sorry. And most importantly, CI actually starts at your local level branches. So since CI is a practice of integrating a code as early as possible, it's very important that you guys follow best practices at your own local level. If we are using Git, there's a feature called pre-commit hooks. So pre-commit hooks execute a functionality each time you commit. And if you apply code linters and other kind of static analysis at a local level, it will actually increase the likelihood of catching a bug early in the cycle. Instead of relying on the remote CI CD system, you should first start applying CI on your local system, because that is the most fastest way to check and get confidence at the code level. And following the next point logically, unit test cases are the first class citizens of CI. So since unit test cases target components in isolation, they are usually very fast and robust enough to signal catastrophe early in the process. And this makes them very suitable for the CI. Then coming back to the integrating code, CI should be consistent enough to be a repeatable process, and that is very important. And integrating the same code multiple times in playback should always yield in the same result. So if your CI is introducing flakiness, or it is producing different kind of results whenever you apply the same cycle on each commit, that is not going to work. The whole point of CI is that your all the processes are in the consistent state. And if I apply same CI on same commit, it should yield the same result. If it failed, it should fail every time. That is very important. Now, coming to continuous delivery. So continuous delivery only happens after CI. It has to ensure that first CI is done, and then we add delivery to it. So continuous delivery starts where CI stops, and it focuses on automating software delivery process so that teams can easily and confidently deploy the code to production anytime. And so focusing on automating software delivery, so continuous delivery includes all the steps necessary to make your software deployable. This includes running comprehensive tests, quality assurance using tools, creation of builds, code signing, generating documentation, and deployment to pre-prod or user acceptance environments. So you can think of continuous delivery as everything except the deployment. You prepare deployment, but you don't actually deploy it to the production servers, and you leave it to human intervention step that will actually ensure when and where to deploy. So it's suitable for teams where continuous deployment is not something that they want. So for example, you're developing a website and you had done a marketing for some feature to come. And so what you would essentially do is that if the release date on Sunday, you would prepare a code on Saturday itself, so that everything is ready, and technology team can be like freed away from deploying responsibility. Now it's a responsibility of the marketing team or some other team, and they can do it anytime they want. So continuous delivery will help you in that phase where you want to remove technology team from that kind of responsibility. And then It leans heavily on deployment pipelines to automate testing and deployment process. So success of continuous delivery depends on the level of automation of software testing and robustness of automatic quality checks. This is the latest stage where critical or breaking changes should be detected and communicated. And it's more important to reject okay seeding changes than to accept them. So if you have any doubt, like if this code is not performing well, or let's assume that it's throwing warnings, so this is the best time you should reject the code. And since industry is moving towards completely automated deployment scenarios, even the warnings should be considered very importantly. And if you have any doubt that this code might fail due to some warning or maybe some deprecated software being used, you should reject that thing from continuous delivery at that point in time. And coming on to the next point, continuous delivery is attractive because it automates the step between checking the code into the repository and deciding on whether to release well-tested functional builds to a production infrastructure or not. And there are many techniques available to deliver functionality and keep it in the dark state without letting your users know. So this includes flag-based activation. This includes environment-based triggering. So, for example, you developed your whole product, you built it, and then you silently deployed it into production. Now, the normal users cannot see this unless and until they have special authorizations from the team, and maybe there are some collaborators. And it's only until it's publicly released everybody able to see those products. The whole point that I'm repeating here is that continuous delivery allows you to prepare everything before the deployment. So then by ensuring that the code base is always in the deployable state, releasing software becomes an unremarkable event without complicated ritual. And teams can be confident that they can release whenever they need to without complex coordination or later stage testing. And finally comes for the continuous deployment. So continuous deployment actually follows after continuous delivery, and it's extension of continuous delivery actually. And it does everything continuous delivery does and takes a further step of automatically deploying the new release or version on the production. So in the previous step, we discussed that it's up to the marketing team or the product team when to release that software. Continuous deployment actually a step further. Now, for example, let's say Chrome, or maybe you have been using Firefox Developer Edition. So these are the software where continuous deployment is automatically applied. And if you might have seen that there are nightly builds that come out every day. So if you have subscribed to their channel, those guys push a nightly build of Chrome every day, so that you can check like what's new in the dev version. So these kind of software are actually without any hassle in between, and as soon as they pass all the requirements and the restrictions from the code base level, the product is shipped to the users directly. The only requirement for a build to be deployed is that the process, the checks and test setup guarantee crash-free experience. Now, since it's a completely automated system, it's imperative that you guys spend more time developing very strict test cases, because here you don't have any chance to like manually review this product. Once it's gone, it's gone. So the continuous deployment should have the strictest rules, as strict as possible before deploying the code, because since it's an automated system and there's no human keeper required. So unlike continuous delivery, no manual trigger is required to deploy a new version to the production. And high confidence build system benefit a lot from this kind of functionality. Then like pushing out 5 new builds to production in a day may not be something that all the teams get comfortable with. And many techniques exist which assist team in selectively rolling out changes to users, such as canary deployments, flag-based deployments, A/B testing environments, and then the dark launches. So GitHub recently published a blog where they showcase a system which would allow teams to continue to deploy new versions of the software, but it would add a layer of reliability over that. So they explain it like this. So for example, you have a microservice running and there's a load balancer, and let's say someday a new developer pushes a new change that passed all your tests. Now this new system is deployed as quickly as possible at that point in time. But what happens is the previous instance is not thrown out. So whenever user requests some kind of service from that kind of application, it will still be served from the older application. And simultaneously, that request will be copied onto the newer version as well. And so the system is intelligent enough that it will try to match the response from 2 systems and then return to the user which came early. So in this manner, even if the new service crashes, the users won't face any downtime because it will be served by the older application. And going further, if like after 1 week or 2 weeks, they find that the reliability scores are actually matching and the new service is responding much like the older service, then they can safely remove that thing. So these kind of techniques actually are required when you want to use continuous deployments. And so as continuous deployment is the last step in the chain of automated pipelines to production, it's imperative that the checks and tests are at this level are the strict tests. Anything less than 100% should be rejected at the outset. Like there should be no leeway. If the everything is 100%, then only you can move it to the production. And then finally, even after all the benefits, continuous deployment is in no sense one size fits all kind of strategy. And teams should validate the requirement and only adopt continuous deployment if the development environment, approach sensitivity, and the test system allows seamless adoption. And if the systems in the place are not mature enough, adopting continuous deployment might prove to be a catastrophic decision for any team. And most teams go with continuous delivery and stop there. And there's no harm in that. So it totally depends on what are you building and how critical is that. And like there's no hard and fast rule that you should actually use continuous deployments. Now coming to the best practices. So the first point, as already discussed, the success of CI CD systems depends on the execution speed. If CI cycle takes huge amount of time for each commit, developers will find an alternative and faster bypasses to get the code integrated very quickly. And this involves pathways which skip tests in favor of optimistic updates. And this can cause havoc in the production. I don't think I even need to mention the consequences of integration untested code. So it's very important that CI/CD is fast enough so that every developer in your team adopts that. Secondly, often ignored, but it's very crucial to protect your CI/CD environment. It's one of the most sensitive piece of infrastructure to protect, as it contains access to your code base and highly other sensitive data. So since your CI/CD pipeline is having access to your code and all the credentials, it's even more important to protect them from the production servers. Furthermore, it's one of the most used systems in the large and high frequency development teams. Any outages on the CI/CD CD can cause tremendous loss of productivity and financial losses in the worst cases. Now, CI/CD pipelines are as successful as the last person using them, and all of the effort in developing CI/CD fails if it's not adopted by the team. So CI/CD should be strictly only the way to deploy to the production. In fact, the rollbacks should be deployed by the same pipeline. And coming to the next point, ability to roll back a change shouldn't involve complex procedures. It should be as simple as possible to roll back a change. And it's always better to roll back changes at 3M rather than debugging them on the prod. And so like, it's very important that the platform you choose for CI/CD should allow easy rollbacks. In terms of Git, if you want to undo any change, Git revert is the first thing that comes to your mind. So similarly, when you reverted any change, it should be like deployed by the same pipeline. And it will essentially roll back the change that you pushed. But today, the newer tools provide you even better functionality where you can just roll back the change by a single click. And if you can ensure that all the changes in your Git repository are coming via merge request, it's even easier to roll back a group of changes. So always keep in mind while developing CI/CD systems that the rollback option is very important. Now, you should run your fastest test early in the pipeline. The idea is to reject the build if it fails any test. And rejecting early saves a lot of time and makes turnaround time really small. And if you think about it, like, so for example, you have 6 tests in your test suite, and you know that one of the tests is like the fastest, and so you should run the test first. And if ever possible, you should run all the tests in parallel because it saves a lot of time. So depending on the infrastructure and where CI/CD built, doing parallelization will benefit you a lot and will keep your CI/CD times very small. So now this point is actually for both DevOps and developers. CI starts as a local development environment, and all basic CI tests should be first run on your local system, as it's very fast and saves time and conserves CI/CD in front of the platform for more critical later stage pipelines. So since whole company is dependent on a CI/CD pipeline, and if you feel that the changes you are doing can be tested on a local system, please do that. It saves the bandwidth. So let's say the other guy in your team is doing some very critical change, and he has to wait just because you didn't run those steps on your local system, and you know that it would fail. So it's very bad on their part. They have to wait for such a long time. Since there is a very limited capacity for CI/CD things, we should always do some consideration that if there's something that can be detected at our own environment, we should do it instead of like wasting the expensive resources that the CI/CD systems are running on. Now, tests should run in ephemeral environment. So in order to provide consistent results for CI/CD pipeline, it's very important that the tests run in a fresh state every time. This is because like if you're reusing same environment repeatedly, the side effects from a previous run might impact your test in future, and this introduces flakiness. And as we have discussed, flakiness is the one root cause that causes teams to abandon CI/CD pipelines. So ephemeral environments are a necessity for making tests idempotent. And these test containers are very suitable, and they make it very easy to provision a fresh environment. So like instead of wasting time in spawning new virtual machines, you should bring back your whole CI/CD in front container-based solutions, because the step to spawn a new container is it's very easy. It doesn't take a lot of time. So like instead of spending a lot of time in cleaning the previous VMs, it's always better to create a new container. And in fact, the most of the offering these days that you will find in the market are the container first. They already run on the containers. And so now coming to GitLab specifically, like how you can actually build your CI/CD pipelines over GitLab. So GitLab has an excellent CI/CD offering for the projects hosted on GitLab as well as other Git providers such as GitHub. And it was surprising for me in the first place, but yes, GitLab allows you to host your Git repository in any of the other providers, but still you can harness its CI/CD system for that. So it's very cool. You don't even have to change your Git provider in order to use GitLab CI/CD. The only requirement to run CI/CD here is that the presence of a special YAML file, and this is called the GitLab-ci.yaml. And this file contains all the instructions and data required to run different CI/CD pipelines. There are plenty of customizations available to shape your pipelines according to your needs. And so specifically, GitLab CI/CD supports all the three stages, namely continuous integration, continuous delivery, and continuous deployment. So because GitLab CI YAML is in the repository and it's version controlled, old versions can still build successfully and folks can easily make use of CI. So since you have now put the logic of CI/CD into your repository, you're free from the worry that CI/CD system might fail and you might lose your data. So now wherever a code lives, your CI/CD is present there, and you can easily shift from like one hosting environment to the other, as long as it supports the same pipeline. And folks can, so I was mentioning that folks can easily make use of CI. Branches have a special different pipelines and jobs, and you have a single source of truth for all CI/CD pipelines. Pipeline is a top level component of continuous integration on GitLab CI/CD, and it comprises of jobs that you define what to run. For example, code completion or test runs. Then stages are defined when and how to run. For example, tests run only after code compilation. And then multiple jobs in the same stage are executed by the runners in parallel. So the point is that multiple jobs and checks combine to build a pipeline which is either passing or failed. Pipelines always have a binary state and nothing in between. And notifications are used to signal the state of CI/CD pipelines, and these should be part of the same source code. So for example, you need a mechanism where you want to notify a developer team that a certain build has been done. So you might either use Slack or email notifications. The point is that you should keep that notification part of the same pipeline, because it's version control. It's always better to have it in single place. And GitLab is created an excellent way to visualize pipelines using directed acyclic graphs in the UI. So maybe you can go on a GitLab and check it out there. I'll show you in the demo again, like how those pipelines can be viewed in a very user-friendly way. And the total running time for a given pipeline excludes the retries and pending. So the thing is that on GitLab, you can start by using your free CI/CD minutes, and those are limited to 500. But these are this duration of 500 minutes is excluding retries and pending time. So you have like plenty of hours to test your CI/CDs on GitLab without paying a penny for that. So I would totally recommend going out and do your first CI/CD pipeline on GitLab itself. And now coming back to the environment variables, variables are dynamically named values that can be used to make your CI/CD pipelines completely parameterized. In general, it's always the best practice to keep to actually remove your hard-coded values and use environment variables to make the jobs portable and provider agnostic. So if you're hard coding something there, so it will actually make your code very brittle. So someday, if you want to move out this pipeline from one provider to another, you'll have to like redo it without, and it won't be possible without modifying the code. So specifically, GitLab has a huge list of predefined variables that can aid to build robust and flexible CI/CD pipelines. And this link can be used to view the list of available predefined values. The most commonly used and important ones actually comprise of commit reference name, commit branch, commit tag, and external pull request IDs. So these variables allow you to shape your pipelines according to different Git branches. And in my opinion, this provides a great flexibility in differentiating jobs based on the environment. So let me just go and share this link. So as you can see, this whole list of environment variables that you can use while developing your pipelines. And I was mentioning about this particular environment variable that is very useful. So you can use this environment variable to run different kind of logic for different branches. So if you're following Git kind of a Git structured development, so what this means for you is that depending on the branch name, for example, master or state, you can run different sets of jobs. And it's very easy to configure that using this environment variable. So had it been hard coded into the pipeline, next time anybody would change the branch, it would be having very difficult for you to change the code again and again. So it's always easy to use environment variables instead of hard coded values over there. It's coming back to the cached dependencies. So every CI/CD job requires some kind of building phase where the test target is built using third-party dependencies. And depending on your technology stack, these dependencies are fetched using plugin managers, modules, importers, etc. So for example, you are using Node. This would mean that you are fetching all the third-party modules using Node npm or yarn. And then similarly, in the Python world, you might be using requirements or txt to use pip to fetch all the dependencies. The common pain point in building with third-party modules across the languages is that it takes a lot of time to fetch dependencies and compile them. And now imagine doing this process over 100 times a day for multiple projects and calculate the time and resources wastage it incurs. So if there was a way to cache these build dependencies and use this cache dependencies for many pipelines, it would make CI build much faster, and it would reduce the bandwidth wastage. And ultimately, it will unclog the CI pipeline so that same infra can be used for much more builds. So GitLab's cache dependencies allow you to do exactly this straight out of GitLab YAML file. And it's as simple as setting a cache directory in YAML file and the key attribute. So just ensure to use the same name of the key in all the jobs where cache directory is used. So I would definitely show you how I am caching dependencies. So in my jobs, what I'll do is that I will just fetch the dependencies once, and I'll not rebuild or fetch dependencies as long as my dependency manifest file doesn't change. So in case of Node.js, if your package.json is not changing, or if the package log.js is not changing, you can be pretty sure that the previous requirements can be still used. So the idea is that you cache these node modules once, store them somewhere, and in the future jobs, when you feel that the package.json has not changed, you can still fetch those dependencies. So it's always faster to download some resource from the internet and unzip it rather than like building it from the scratch. And the Node.js developers should know the feeling, like how it takes a lot of time to fetch all the dependencies and build them on every commit. So Now, the common practice to ensure cache between branches is to use Git-based environment and use variables such as cache key. So a cache key ensure that that you are fetching the right file for the job. So, for example, if you set a cache key by your commit branch name, so all the jobs that will run for the same branch will use the same cache, and that ways you can be pretty much sure that you don't need to fetch all those dependencies again. Now, the most important point while using cache dependencies is that you should actually invalidate the cache when you're not using them. And GitLab provides you powerful primitives to invalidate cache. And this can be done either via UI or by clearing the cache key. So there's a limit till which you can cache files in the GitLab for free plans. And I would suggest you that you should be deleting the caches after some period of time to keep that buffer for your future jobs. And an extension point here would be like you can optionally fetch dependencies and build them only when the package manifest file changes. And this is very superior to using cache always. So as I'm already mentioned, only fetching Node.js dependencies whenever the package changes. So now coming back to triggers, like how can you trigger the CI/CD pipelines? So the easiest way to trigger CI/CD is by performing any Git-based operation, such as pushing in a branch, merging a pull request, or creating a tag for which handlers are mentioned in the GitLab YAML file. So this is the most frequently used and the most convenient method to trigger your CI/CD. So if you have your repositories in GitLab and you have a GitLab CI file, so you can define that a particular job should run on pushes. Some jobs should run on the merge request pulls, and other ones only when a special operation is performed, such as creating a tag, git tag. The second option that you can use to trigger your CI/CD jobs are webhooks. So webhooks provide a very convenient method to trigger CI/CD on demand by making an HTTP post call to specialized URLs. This is very useful for event-based triggering, where webhook can be called whenever the required event occurs. For example, you can set up a cron to run your nightly builds on GitLab by just hitting the curl request on webhook URL at the desired interval. And like any other event can also be used as long webhook can be hit in some response. So you can configure any kind of event on your end, and the only job you have to do is like hit the specialized URL, and your GitLab pipeline will run in that response. So GitLab has a provision for the manual intervention by authorized users as well. So in the GitLab YAML file, you can mention a part of your pipeline to run only after somebody with the access in the team can resume the job from the UI. So this feature enables constructing continuous delivery pipelines that we have already discussed. And everything except deployment can be automated, and only after the manual intervention, the deployment can take place. So I'll show you how to do this in the practice in the demo. So last point before we move to the demo is there are like two special keywords that allow you to add any amount of flexibility in your GitLab pipelines, GitLab CI CD pipelines per se. And this feature is only limited to GitLab, but this only at the syntax level. Other providers also provide such kind of flexibilities via some other variables. But specifically for the GitLab, only except are your two things that you should always use to configure the pipelines. So these constructs are the nut and screw that GitLab CI CD pipeline and that allow customization. So only defines the name of the branches and tags for which the job will run. And for example, except defines the name of the branches and tags for which the job will not run. So you can add any kind of condition in which your job should run. So most importantly, you need to keep some rules in mind that only and except are inclusive. So if both only and except are defined in the job specification, then the ref is filtered by only, nothing else. So then only and except allow use of regular expressions. This is really interesting features and make any kind of customization possible by playing over the strings. So for example, you want to run a job for the branches which start by name release, or maybe start by the name of test. So this is a very powerful feature that you can do here very easily by using only and except. And only and except allow you to specify repository paths to filter jobs for forks as well. So if somebody has forked their GitLab repository, so you can limit only except to allow that job only to run when some change has been pushed to your original repository rather than the forked one. Some of the interesting values that can be applied over only and except are the branch names, tags, and there's a special keyword called merge requests. So if you apply a condition with only of merge request, so that pipeline will only run whenever somebody raises a merge request. So you can also use multiple keys under only and except, and these keys will be evaluated as single co-joined expression. And so that is only means that include this job if all of the conditions match, and except would mean that exclude this job if any of the conditions match. With only, individual keys are logically joined by and. So if you use the only parameter and specify multiple conditions, so these conditions will be actually translated into a Boolean operation where all the conditions will be necessary in order to proceed there. So even if one condition fails, that pipeline won't run. And this also means that this relationship could be described very easily as using your Boolean operators. And then huge list of attributes that you can use with only and except. So you can actually go there on the link and see what all variables are available there. So yes, here's the advanced sections. As I mentioned, the REST variables, changes, and the Kubernetes. These 4 keys are available by default, and you can use any other values under these keywords to make your pipelines as flexible as you want. So there are some goals for demo that there should be a separate CI and CD pipeline, human gatekeeper interaction for each deployment, and the segregation between release and deployment. This is very necessary. And what it means that code should be allowed to get merged into the master branch, but it should not be released automatically. It should only be released by creating some special event that only a manual that can be done only manually. So and then coming back, we will be seeing how we can leverage cross-border testing with LambdaTest, and most importantly, using your LambdaTest local tunnel. So there are cases where you are developing a website locally and you still want to do some cross-border testing without exposing it to the internet. That is where LambdaTest tunnel comes into the picture. So LambdaTest tunnel is an agent developed by a team at LambdaTest, and you can actually install that on a personal system. And once started, it will allow you to it will allow my browser VMs on the cloud to access the internal website that you're hosting. So what this means is that after running this agent, you can run Selenium scripts, which can test your local host websites on the remote browsers. So it's kind of a proxy that sits on a machine and allows the remote browsers on remote providers to access your local host and other internet traffic. So the project that we'll be using today for CI/CD demo is Hourglass, and so I made it in 2018, and it's a MERN stack app. So it's a simple time management app using the best practices available at that time. And so unfortunately, in the JS world, those best practices change every month. So some of these might have been updated, but like 90% of this is still relevant. And this is a full production scale and production styled development repository, and it is full of all the best practices available. And let's go on the link and see how this repository has been developed, and like how you can contribute to it. So for today's tutorial, I have mirrored this repository from GitHub to GitLab in order to use GitLab CI CD in an efficient way. So here's our project, and as you can see, there are storybooks. So storybooks is a testing tool in the React world where you can visually test visually test the components in isolation and something like that. So as we discussed that we want to do continuous delivery instead of continuous deployment, because there might be some features that I don't want to readily deploy automatically. So here we'll decide how to do that using a demo. As I mentioned earlier, that there's a special file it's called GitLab CI file. So we'll see that how that file is available here and how it does all stuff for us. And so changing the branch to master. Here's that file. There's a magic file that contains all the logic. So since it's a YAML-based file, you can write a one normal YAML constructs here, and it will work out of the box. So I'll go line by line, explain you what we are trying to achieve here. So like the first thing that you can see is the image. So as I mentioned that CI/CD should run in ephemeral environments, and GitLab is using Docker. So this image tells you what is a base image over which you want to run your CI/CD jobs. So since my project is on the MERN stack, MERN basically stands for Mongo, Express, React, and Node.js. So like this is a very popular stack amongst JS developers and for backend and both front-end development. So since my project is based on Node.js, I have chosen this version and particularly pinned this version there just to ensure that my builds are always consistent. Now, this is very important. Had I not mentioned this version, it would have picked up the latest image. Now, what happens is like whenever when I developed this project in 2018, this was the stable version. Now, if I would run this now, it would have fetched the latest version, that is Node.js 11 or 12. And it might have break my dependencies. So just to avoid that kind of situation, you should always pin down the particular version. Now coming back to the stages, so stages is just like an index of a book. So stages tells you that what all is being accomplished in this pipeline, and it gives a very broad summary of what all you have designed in this pipeline for. So I think the names are like meaningful themselves. So install dependencies will install my Node.js dependencies. And as I already mentioned that I will only trigger this job only when my yarn.log changes. So I'm using yarn here instead of npm because it's superior, it's faster, and it does the same thing like fetching my node modules, but in a faster manner. So similarly, like package log.json, yarn uses its own file, yarn log. So whenever you add or remove any dependencies, this file changes. So like this check is very appropriate here, like only do this job when yarn log changes. And if the yarn log is same, don't do this. So what will happen when you don't execute this install dependencies later stages, that we will fetch the cache dependencies that we have built in the first version. So for the first time when this install dependencies run, it will cache the node modules folder using this key. So since we've already studied that we can use environment variables here, so this will make my condition more robust. So this is CI commit reference slug. So basically, you can imagine it as a branch name, but with some text modifications such as lowercasing all the values. And then with hyphen, I have added the project directory. So this is pretty much constant value, but the left one will change depending on the branches. So what this means essentially is that for every branch, I am caching my node modules until my yarn log file changes. So coming back to the next thing, this is the unit test cases that I will run. And as you can see that whenever a new job runs, it will run in a separate container. So in order to avoid fetching the dependencies again, I have used this attribute like cache. So what it will do is like it will fetch the cache node modules from the previous step here, and I don't have to do it again. Only thing I have to do here is yarn test. So inside script attribute, you can enter your shell script that would run in a normal shell, and you can add multiple values for this. So just imagine that you are executing a bash file on your system, and you can just copy paste all the commands that you write there inside the script tag. So coming on to the next thing is the integration test. Now, only run this case in case of continuous delivery. Now, what it means that I don't want to run this test every time. This test should only run when somebody is trying to merge their repository into the main trunk of my Git system. So for this particular demo, what I've done is that I have limited this job only for the merge request and for the prod branch. So if you do any kind of change in non-prod branches, this change won't run there. This is only meant for integration purposes because it will take a little bit more time. So as we discussed earlier, that we should keep our CI/CD pipelines very fast. We should be very considerate, like what kind of job we are trying to run. So it's taking more time. It should be run in the later stages. So here you will see a new keyword called services. Now what happens is that in my integration test, I'm using MongoDB instance. Now, GitLab allows you to run any third-party services in conjunction to your already running job. So let's say my integration tests depend on Mongo. So I don't need to bring my own Mongo cluster. I can just ask GitLab CI CD to run a Mongo Docker in addition to my the container in which my jobs are running, and create an internal networking as well. So what we'll do is that it will spawn a separate container and link it to my running container so that I can use Mongo from my local script set. So here what we've done in doing that, we are just echoing the Mongo URI test. Now this is a very important trick that you can use to debug your CI/CD pipelines. So since we have ensured that our pipelines are using environment variables, there might be cases when these variables are like out of your knowledge, like which ones did actually the CI/CD pipeline used. So you can always do some echoes and it will display in the log like which Mongo URI tests were running over there. Now coming to the next job, it's linting. So linting is more like checking if the code meets my guidelines that we have already planned. So this is a very fast job. It uses ESLint internally, and we can do it every time, and just ensuring that we are fetching node modules because ESLint is only the node modules. Now, here comes the end-to-end testing. Now, this kind of testing does take a lot of time, and it should only be done when we are final to, I mean, we have already done everything, and we just need to double check that we are doing it correctly. And particularly for the website, this means that now the website was working on your system on a particular browser, but now we need to check if this website works on all the different browsers. And here's where your cross-browser testing comes. So in end-to-end testing, what we'll be doing is that we'll be starting a backend server, we'll be starting a front-end server, and then we'll be running a Selenium script on the Lambda test using Lambda test tunnel. Now we're using Lambda test tunnel because we haven't still deployed a website, and this website will be residing in the container itself, and it will be accessible by localhost. Now, in order to come this limitation, we'll use Lambda test tunnel, which will proxy the traffic from my container to Lambda test browsers, and it will be able to test that. So then other thing is the build client. A build client is what it's finally creating a production build for my front-end assets. And here you can see a special command that I've added. It's called artifacts. So artifacts, GitLab artifacts allow you to cache some resources, and it's available for download from the UI. So let's say you did your final production build, and now you want to access it later after the CI/CD has ended. So you can create an artifact for that. By doing this, you'll be able to access those static files later on, like in any point in time after you have run your CI/CD test. So these are like very simple jobs. So basically, these are only done as a final touch when you're ready to deploy. So they're building documentation, building storybooks, and everything else. And this is where this is actually deployment step. And these are broken down into separate steps because we don't want our code to be deployed automatically. So for this, what we've done is we have added when and manual tag here. This tag tells GitLab that this process should only be run when triggered manually via human intervention. And the next command follows that you don't want this command to fail. I mean, if this command fails, the whole pipeline should error out. So this is how we achieve that kind of system where my production builds are done and they're ready to be deployed, but only be deployed when I want them at my will. So we'll see like how this actually takes place here. And there's one more thing that you can add is since these jobs can run in parallel, you can ensure that a certain job should only be run when a previous job has completed. So as you can see here, there are dependencies for E2E tests. Now this deploy command should only be available for manual intervention only when the E2E test has been completed. So there's no point in like deploying my backend before I have completed my test. So this thing ensures that this step will only be unlocked when my previous test cases have been passed. And similarly, there's another command for deploy front end. And similarly, I've added when manual. This should be triggered manually whenever you want it. So what we'll be doing here is that this is an application. This is a target application that we'll be using. So it's a very simple time-based application. Maybe we can create an account. So since this is deployed in very small servers due to freebie registry, these will take time, and also the servers are located in Europe and US, so there's some latency involved. But this is the project that we are going to test here. So okay, this is taking a long time. Maybe we can switch back to our CI/CD pipelines here. So let's do one thing. We'll go ahead and do some change, a very small change in the README file to trigger our CI/CD pipeline. So in order to do that, we can do changes right away from the web IDE. And let's take up the README file. So let's commit this change, and this we need to ensure like which branch we are doing this change in. So let's change branches. Let's do this change in the master. Now, since we have added CI/CD pipelines, GitLab detected it automatically. And what we'll do here is that we'll straight away jump to the CI/CD section here and see like what happened. So as you can see, when as soon as I push something into the master, my job ran. So there are only two things that are running here. So one is the build client, and one is the linting and unit test cases. That's it. So since this is a normal CI step, I just integrated a code into my master branch. So I just need to ensure that the code is meeting my specifications. Now, like when you are done with doing this, and we are raising a pull request to the prod branch. So for this purpose of the demo, we are treating the prod as a main branch of the Git repository. So master is not the one. So let's say we want to merge from master to prod. And right, let's not delete this and submit the merge request. So now, since GitLab knows that there's a pipeline attached, and so what it's doing is that it's deferring the merge until the pipeline succeeds. Now, this is a very interesting feature that GitLab provide you. So it won't merge before your test scripts are done. But you don't have to sit on the screen to wait for the scripts to end. You can just click this option. So whenever the pipelines will succeed, this branch will be automatically merged. So I mean, it's a very easy to just like send a pull request and start doing your other work. You don't have to wait for that pipeline to complete. Now, what happened in response to creation of this merge request? So now what's doing is it's building documentation, it's building storybook, and then it will run my integration test only when this process is complete. This might take 2 or 3 minutes because as I already mentioned that GitLab run these tests on containers, and these are container very low specifications. So these do take time, but let's dive into what's happening in this job. So this is very interesting. You'll get all the logs in timely manner to like what's ever happening in the job. So as you can see that first of all, it tried to fetch my repository there. Then it tried to check if the cache exists. Like this cache is of the node modules that we discussed. Like it would the node modules would have been fetched in some previous jobs, and now we can use that here. Since it successfully extracted the code, and I started the building documentation, and it's now complete. So this job is now complete. As you can see, this passed here. Now going back, let's see, I mean, at what stage my pipeline is in. So here, The build client is passed and it's waiting on lint and unit test cases. So all the jobs in the same stage will run in parallel unless you specify otherwise that you want a particular job to depend on some previous job. So since linting and unit test cases don't have anything in common, I've decided to run them in parallel. So running them in parallel will decrease my CI time. And similarly here, as you can see, in response to a merge request, another job is running, and that is the integration test. So integration test means that now I want to check if my backend and front end are compatible together and the APIs are working here. So these tests will occur in this stage. And since we are dependent on the MongoDB instance, this CI CD pipeline has fetched a MongoDB image from the Docker Hub. It has set it up like automatically. And then when everything is done, it will start my test cases. So in the meanwhile, when this is being done, let's see how we can prepare our code base for the release. So for the release, in this demo, what I've done is that we need to create a tag whenever we want to freeze some kind of release. Now, Git tags are very useful if you want to like bookmark some important changes there. So let's do one thing. I create a new release and I will create from the master branch. You can add any message over there just to keep you reminded like what this main release contains, or maybe you can add some build release checkpoints as well. So as soon as I create tag, this will start my release process. Now we can straightforward go to CI CD. And now we can see this top row, this new pipeline has been created in response to my tag creation event. What we'll do is, first of all, install dependencies because we are now creating the final build. We don't want any confusion in that. So we are doing every steps possible to ensure that this is the final release and it doesn't contain any kind of bugs or warnings. Secondly, after the build will be created, it will try to build the client. In third, it will run three kind of tests now. It will run unit test cases, linting, and then end-to-end tests. End-to-end tests is where we'll use cross-version testing in order to test on LambdaTest. And then finally, when the test cases have passed, it will move on to the deploy backend stage. And most importantly, these stages are manually triggered. These steps won't happen automatically. So I'll just show you. You just need to wait for a while when this pipeline completes. So you can see in the previous cases that this is how you can actually achieve that kind of manual intervention. I ran this job like an hour ago, just for the showcase purposes. So like when all these three have done, the play button will be unlocked. Now this is where you can manually intervene and run this job again. So if I do this, it will start deploying my backend again from that particular release itself.
Yes, exactly. So we have passed our all test cases, unit test cases, we have done linting, and we have done end-to-end test cases. So let's see, what logs did it generate? So first of all, we tried to run our backend server using PM2 here. Then we tried to run a file server, static file server. And then finally, inside my just cases, I tried to spawn up a LambdaTest tunnel using a plugin. So as you can see, that tunnel is successfully initiated here. And from that point, just started its normal testing. And this test should appear here also. Let's refresh the page. Yep, I think this time matches. And this is the test that we're talking about. Yes, so test is working and we can see the network logs as well. But I don't think we have enabled it. So in order to capture network logs, you need to pass the capability over there. So I think I missed that part. But the commands are recorded here for your debugging purposes. And then as Buddha mentioned, you can always use Selenium logs on LambdaTest and the console logs if they are available. Yes, we have some console logs as well. So coming back to our CI CD pipeline, now we have done all the kind of testing and we are sure that this release is ready to be deployed. And let's say the day comes when I want to release this, it's as simple as clicking this play button and that's it. So now these jobs will run only when you want. So what this did to you is that it prepared the release process for you, and it took away all the hassle from doing those last minute checks, last minute testing, because you're now sure you did all the kind of testing beforehand, and now you can safely deploy and just relax. So eventually, what will this do is that it will deploy my backend on Heroku and my front end on Surge. So yes, boom. So like our front end is now deployed in Surge and my backend is deployed in the Heroku, and this is done automatically via my CI CD pipeline. So like this is how you can actually make a CI CD for your own company or team there.
As always, please post any questions in the comments below or at community.lambdatest.com.